Hi everyone, this is Dr. Mark Riggs, and in this video I want to discuss the cornerstone of our practice, which is functional medicine. Specifically, I want to discuss what functional medicine is, how it can help you, and how functional medicine is in most ways superior to conventional medicine at both diagnosing and treating chronic disease. It's important to understand that we're in the midst of the worst chronic disease epidemic in human history. Worldwide, over 1 billion people suffer from diabetes and obesity combined. Obesity in adolescents has quadrupled in the past 30 years, where now almost 20% of kids aged 6 to 11 are obese. More than 600,000 people in the United States die from heart attacks each year. 1 in 4 women and 1 in 6 men suffer from an autoimmune disease. Over half of adults take prescription drugs, and 90% take over-the-counter drugs. 40% of the elderly take more than 5 medications. According to the CDC, autism prevalence has more than doubled since the year 2000, and that's not just due to increased reporting. The number of people diagnosed with depression increases by 20% every year. And unfortunately, things look like they're going to get worse before they get better. As you may have heard, it's looking like this is the first generation of kids in modern history estimated to live shorter lifespans than their parents. Additionally, if current trends continue, in 2 decades, 95% of Americans will be overweight, and 1 in 3 will have diabetes. The consequences are extremely profound. The cost of diabetes alone is $250 billion a year. And just to put that into perspective, the World Health Organization estimates that the cost of ending world hunger is only about $200 billion. And that's pretty staggering considering this is less than we'd be spending every year for an almost entirely treatable and preventable disease. If healthcare spending continues to increase at the current pace, the U.S. is estimated to be bankrupt or insolvent by the year 2035. Additionally, our annual healthcare expenditure hit $3.8 trillion in 2013, which equals 24% of our gross domestic product. And with all this financial expenditure, you'd expect the United States to have incredible healthcare. We should be reversing and preventing disease and doing minimal harm while we're at it. Unfortunately, studies and recent statistics show that it is just the opposite. In fact, a study in the Journal of the American Medical Association in the year 2000 concluded that medical care was the 3rd leading cause of death in the United States. Each year, medical errors are responsible for 200,000 extra deaths, $77 billion extra dollars, 8 million hospitalizations, and 77 million extra drug prescriptions. So why is our healthcare so ineffective? Well, it's because it's not actually healthcare, but rather disease management. And don't get me wrong, modern medicine is amazing in many ways. We have the best emergency medicine and trauma care on the planet, which has allowed us to live longer than ever before. We can reattach limbs. We're able to restore sight to the blind. And in our lifetimes, we may even be able to fight cancer with nanorobots. But a few things conventional medicine is not very good at is promoting health or preventing and treating chronic disease. It's no secret that conventional medicine and our healthcare system as a whole is mainly focused on suppressing symptoms with medications. High blood pressure, high cholesterol, diabetes, depression, you name the symptom, and there's a pill for every ill. There's almost never, however, any investigation into the underlying causes of those symptoms. Now, there's definitely a time and place for medications, and some are certainly much better than others, but there are 4 fundamental problems with basing care on drugs. Number 1. Drugs rarely address the underlying problem. Imagine you have a pebble in your shoe making your foot hurt. You could take painkillers to reduce the pain, But wouldn't it make sense just to remove the pebble? Number 2, drugs don't just suppress symptoms, they suppress functions. Many patients take nonsteroidal anti-inflammatory drugs like Motrin to cope with arthritis or inflammatory conditions. And while they may be effective at treating and managing pain, they also reduce blood flow to cartilage, and since blood carries nutrients and immune substances for tissue repair, drugs like NSAIDs, when taken long-term, can actually worsen a problem like arthritis. Number 3, drugs often correct one imbalance by causing other or several other imbalances. If a drug interferes with one protein, it inevitably affects many others. This causes what are referred to as adverse effects or unintended effects. And often, the unintended effects of a medication outnumber its intended effects. Number 4, our biological systems are inherently redundant. This means that the same molecules have many different effects in the body. Histamine, for example, plays an important role in inflammation in local tissues as part of the healing process. But in the brain, it increases the function of neurons. Therefore, when you take an antihistamine to suppress an allergic rash, it also affects histamine receptors in the brain and causes drowsiness. That's why medications like Benadryl are taken to put you to sleep. So we're in desperate need for a new approach to medicine, one that emphasizes actual health care over disease management. And this new medical model would have 3 main characteristics. First, it recognizes the exposome as the primary driver of health, and I'll explain what the exposome is shortly. Second, it embraces an evolutionary or an ancestral perspective to diet and lifestyle. And third, it applies a functional medicine approach to care. So number 1, the exposome is the primary driver of health. The exposome concept was originally proposed by Dr. Christopher Wilde in 2005. It represents the sum of all non-genetic exposures in an individual lifetime starting from the moment of conception. It also encompasses the food that we eat, the air that we breathe, social interactions, lifestyle choices, and inherent metabolic and cellular activity. The exposome contains 3 categories. Specific internal consists of diet, water, physical activity. General external consists of the environment, air pollution, social interaction, and our climate. And internal factors such as metabolism, hormones, our microbiome, inflammation, etc. These influences are key as we now understand that the factors involved in the exposome are the primary drivers of disease, meaning our disease risk is primarily caused by our environment. In fact, recent estimates by the World Health Organization state that 50% of mortality is related to air pollution, smoking, and diet. At one point not too long ago, it seemed genetics would hold the key to health. In the 20th century, the discovery of DNA, the PCR method, and mapping the human genome led to concepts of biological determinism. This is the idea that human health was controlled by our genes. Unfortunately, the theory of biological determinism didn't pan out, as limitations of using genes to predict and prevent disease quickly became apparent. Ironically, Craig Venter, one of the first to sequence the human genome, was also one of the first to recognize its limitations. We now know that genetics account for less than 10% of disease. The remaining causes are environmental or related to the exposome. The majority of mutations of a single gene, known as SNPs, are highly prevalent, but most have low penetrance, meaning they don't often manifest in disease. We know now that genes only manifest in disease in the presence of specific environmental exposures, and that is very, very key to understand. In other words, genes may load the gun, but environment pulls the trigger. This relationship between our genes and the environment is known as the field of epigenetics. The simplest definition is that changes in gene activity don't involve alterations of genetic code, but they still get passed to at least one successive generation. DNA was originally considered to be a template or a mold, and if you were to pour raw genetic material into the mold 100 times, you'd get 100 identical copies. And this goes back to the idea of biological determinism, the theory that genes run the show. We now know that this is not the case, and a better analogy for the relationship between our genes and our environment is like a film or a theater production. The script is like our genes, and the cast, crew, costumes, and director are like our environment. So for example, Romeo and Juliet. The script for Romeo and Juliet hasn't changed since the last 1500s, but it's been performed and produced in hundreds, if not thousands, of different ways. If a script is terrible, even a great director can't save it, and a great script won't matter with terrible production. In other words, while genes are still important, our environment and how genes are expressed are more important. This explains why identical twins are similar but not exactly the same. Identical twins are matched for genes, age, sex, pregestational environment, and usually post-gestational environment. And while it's true they have higher risks of developing the same diseases, those risks are not 100% equal, which would be the case if the theory of biological determinism were true. In fact, we see discordant rates of up to 50% in identical twins, even in highly heritable diseases. Schizophrenia is a good example. If one twin has it, the other twin only has a 50% risk of developing it. This further supports that the exposome and epigenetics plays a more important role, even in diseases with a strong genetic component. The agouti gene in mice causes the production of a yellow instead of black coat. It's also associated with higher risk for obesity and diabetes. But when methyl donors, like vitamin B12 and folate, are given to pregnant mice, the agouti gene is silenced in their offspring. The agouti gene doesn't express, and the offspring will be lean with a dark coat. This is also true of the offspring's offspring. Another example in mice showed that behavior and cognitive function was subject to epigenetic influences. Researchers exposed mice with genetic memory problems to an environment rich in toys, exercise, and extra attention. These mice ended up showing big improvements in memory formation and cognition, and amazingly, the mice's offspring also showed improvement despite no extra attention. We don't just see this in animal studies, but in human studies as well. One of the best examples is the Dutch winter hunger cohort, where a group of people who lived through a period of famine in Holland between November of 1944 and May of 1945 during World War II. In this case, food rations were less than 1,000 calories per day. Babies in utero during this period suffered from a range of adverse effects later in life, including higher rates of obesity, diabetes, cardiovascular disease, personality disorders, depression, psychosis, and more were likely to be infertile. Another example is the Norrbotten cohort. This was a snow-swept, sparsely populated area of northern Sweden that was so isolated it was entirely dependent on harvest. A doctor named Lars Bygren drew random samples of 99 people born in 1905 and used historical records to trace their parents and grandparents. He analyzed agricultural records to determine food availability and found that boys who enjoyed rare, overabundant winters had a higher risk of obesity, diabetes, and early death. On average, their lifespans were 6 years shorter than other boys, and this was true for their offspring as well. All of these examples illustrate the role of the exposome and epigenome in health. in particular, the importance of early life exposures. So what does this all mean? It means there's bad news and there's good news. The bad news is the choices that your parents and grandparents made affect your disease risk today, and the choices you've made affect your kids and grandkids. The good news is that genes are not your destiny. Lifestyle and environmental changes you make now affect genetic expression and health risk in real time. This truth makes focusing on the exposome, a healthy diet, and lifestyle that much more important. In previous examples, not everyone at higher risk acquired disease or died early. The environment was probably the main factor that determined who got sick and who stayed well. So although we can't control how our parents and grandparents lived or our genes, we can control our current diet and lifestyle, thereby affecting gene expression. Number 2 in this new model of medicine, we want to embrace an evolutionary perspective to diet and lifestyle. Evolutionary biologist Dubinsky said, "Nothing in biology makes sense except in the light of evolution." And what did he mean by this? That all organisms are adapted to thrive in a particular environment. And when our environment changes too fast, biological mismatch can occur. This is a fundamental principle of evolutionary biology. For roughly 65 to 70,000 generations, humans ate meat, fish, wild fruits and vegetables, nuts, seeds, and starchy plants. We were physically active, didn't sit long periods of time. We were in sync with the natural diurnal rhythms of light and dark. We lived in direct contact with nature and in close-knit tribal groups. Our ancestors, contemporary hunter-gatherers, were lean, fit, and free of chronic inflammatory disease. They were also superior to us in almost every measure of health and fitness, from BMI to blood pressure to insulin sensitivity, oxygen consumption, vision, bone density. So what about the argument, so what? Didn't they die when they were 30? While true they did have shorter lifespans on average, those averages don't take into consideration certain challenges they faced which are not common in our modern lifestyles, including trauma without access to emergency medicine, accidents, exposure to the elements. But when these factors are considered, their lifespans are estimated to be nearly equivalent to our own, but without chronic inflammatory disease that characterize modern man's old age. There was no obesity, no heart disease, no diabetes, gout, hypertension, and most cancers. So where did we go wrong? What transformed us as a species from healthy, vital people, free from chronic disease, to sick, fat, unhealthy people? The answer is it was a 1-2 punch. Agriculture was the first blow, which scientist Jared Diamond called the worst mistake in human history. Originally, hunter-gatherers were virtually guaranteed a healthy diet because of the diversity and nutrient density of the foods that they ate. Once human beings settled down, they started farming, which caused a major and abrupt shift in the human diet. Overall, our average carbohydrate intake skyrocketed while protein intake plummeted. The quality of the protein also decreased. You can see that all animal protein is more bioavailable than any plant protein. Soybeans are close to beef, but they contain phytate. Notice how low wheat and wheat protein are. Also notice that legumes are on average much lower. Vitamin shortages became common as our new diet relied heavily on limited set of crops such as wheat, rice, and corn. Our diet was also lower in most nutrient-dense animal products, which led to diseases like beriberi, pellagra, rickets, and scurvy. It also led to tooth decay and anemia due to iron deficiency, an increase in infant mortality, a decrease in average bone density, and all of these diseases were rarely experienced by our hunter-gatherer ancestors. Human beings also shrank. Archaeologists found that the average height for hunter-gatherer at the end of the Ice Age was 5'9" for men and 5'5" for women. And after agriculture, 5'3" for men and 5 feet for women. The second blow in the 1-2 punch was the Industrial Revolution. There's no doubt agriculture led to a decline in overall health, but the Industrial Revolution was the knockout. It brought us to where we are today, with white sugar, flour, vegetable oil, etc. making up 50-70% of our calorie intake on average. We're more sedentary than ever before. We sit while we're at work, we sit while we play, and we sit while we rest. We're also chronically sleep deprived, as 33% of Americans sleep fewer than 6 hours per night, and this is up from just 2% of Americans sleeping less than 6 hours per night in 1965. We're working harder than ever. Both men and women are working 12 to 13 more hours per week today than in 1968. Stress levels are off the charts for most people, as we feel like we don't have enough time for rest and leisure. And even when we do go on vacation, most of us never completely unplug. We compulsively check our emails, social media, etc. Finally, most of us live and/or work in isolating and alienating social environments where we are disconnected from the natural world we evolved in. Now, it may seem like this has been going on for a while, but if you think of it this way, think of human history as a football field. This means that for the first 99.5 yards of that football field, humans lived as hunter-gatherers. It's only the last half of a yard that we developed agriculture, and only the last few inches that the Industrial Revolution occurred. This profound mismatch between our genetic heritage and these relatively new environmental changes are what are thought to be responsible for the epidemic of modern disease. It also helps explain why adopting a Paleolithic diet and lifestyle has helped so many people. Number 3, we want to apply a functional medicine approach to care. The best way to describe functional medicine is really to contrast it with conventional medicine. And in some ways, this won't necessarily seem fair because I'll be presenting the best case of functional medicine against the worst case in conventional medicine. And as I said before, conventional medicine is great when it comes to dealing with traumas, emergencies, and other methods of acute care. But we can all agree that conventional medicine is failing us when it comes to diagnosing and treating chronic disease. And chronic disease is really the number one we as Americans face. First, functional medicine is investigative. It treats symptoms by addressing the root causes of problems. This leads to a more profound and longer-lasting result, whereas conventional medicine is more superficial. Conventional medicine's goal is to mask or suppress symptoms, but doesn't usually address causes of those symptoms, thereby creating patients for life. For example, pretty much anybody that you know taking a high blood pressure medication or high cholesterol medication, their provider usually has no intention of ever removing them from those medications. Functional medicine is holistic. It treats the body as an interconnected whole and recognizes that in order to treat one part of the body, that other parts typically have to be addressed. Conventional medicine, on the other hand, is more dualistic, viewing the body as a collection of completely separate parts. In fact, this explains why there is a doctor for every part of the body. And sometimes, maybe often, there's not a whole lot of communication between specialists. Functional medicine tends to be more safe, and treatments typically are associated with fewer adverse effects, risks, or complications. We emphasize diet, lifestyle, supplements, and herbs, and often Unrelated complaints improve spontaneously. Conventional medicine, on the other hand, is inherently more dangerous, revolving around drugs and surgeries, with more serious adverse effects and complications, up to and including death. Functional medicine is patient-centered. We treat the patient, not the disease. And we recognize the individuality of each patient. So there's no one-size-fits-all treatment protocols like there are in conventional medicine. Patients with the same condition, therefore, may get very different treatments. Conventional medicine, on the other hand, is disease-centered. Conventional medicine focuses on the disease as opposed to the patient. And therefore, patients with the same disease or similar diseases may often get the exact same cookie-cutter treatment despite the patient's individual differences. In functional medicine, the patient is respected, empowered, educated, and encouraged to be active participants in their health care. In conventional medicine, on the other hand, patients' opinions are often discounted or ignored. Little time is spent on education, and the patient is actually discouraged to being an active participant in their health care. Functional medicine is integrative, combines the best of allopathic and alternative treatments. Functional medicine practitioners don't exclude drugs or surgery when they're necessary, but we tend to focus more on the cornerstones: diet, lifestyle, and other things like supplements and herbs. Conventional medicine is more limited, relying almost exclusively on drugs and then surgeries despite their inherent risks. Functional medicine is also preventative. It's guided by the ancient Chinese proverb, "A superb physician treats the disease before it occurs." Conventional medicine is, on the other hand, reactive, managing diseases after they occur. Often, conventional medicine doesn't intervene until the disease has progressed beyond the point of no return. So we at 5280 Functional Medicine have adopted a systems model of functional medicine. At the core, the relationship of the exposome with the genome and epigenome. This is the most important factor to consider because of the interaction between genes and the exposome and how that affects epigenetic expression. These factors, as we've already talked about, determines health and underlies all disease. The next ring around the exposome and genome and epigenome is pathology. When modern diet and lifestyle and environment affect expression of genes, this leads to pathologies, which are defined as deviations from normal physiology that characterize and constitute disease. In short, they are mechanisms that give rise to disease. So examples would include SIBO, low stomach acid, gut infections. These are all pathologies that underlie conditions like irritable bowel syndrome, inflammatory bowel disease, and GERD, or gastroesophageal reflux disease. Insulin and leptin resistance and inflammation pathologies give rise to type 2 diabetes and metabolic syndrome. Impaired methylation and mitochondrial dysfunction give rise to things like anxiety, depression, and ADHD. Pathologies are then grouped into diseases and syndromes. A disease is a disorder of structure and function that produces specific signs and symptoms. So, for example, type 2 diabetes is a disease. There's cardiovascular disease, acid reflux disease, Alzheimer's disease, Parkinson's disease, cancers, etc., etc. Syndromes are a group of signs and symptoms that appear together and characterize an abnormality. Conditions like irritable bowel syndrome, premenstrual syndrome, fibromyalgia syndrome, etc. Finally, the outer ring are symptoms. These are outward manifestations of diet and lifestyle and environment leading to pathology and disease. Conventional medicine typically approaches treatment from the outside of this graphic inward, suppressing symptoms with drugs or surgery, and quote-unquote managing disease, maybe slowing its progression, but the patient ultimately lives with the disease and symptoms. The functional medicine approach, as we've already gone over, approaches this diagram from the inside out, starting with diet, lifestyle, and environmental factors, correcting pathologies in order to address diseases and symptoms. It's a fundamentally different model and approach to healthcare, and what I believe should be the future of medicine. Thanks you guys so much for listening.